Today I'm going to show you how to graph a proportional relationship or to tell whether a graph shows a proportional relationship. To graph a line from a table, all you're doing is taking the ordered pairs from the table and graphing them on the line. Every column has an x value and a y value that are paired together. In my first column, I have an x value of 1 and a y value of 2. So that gives me an ordered pair. Remember, our ordered pairs are in the order x, y. So my first ordered pair is 1, 2. To plot that, if you remember, our x-axis is our horizontal axis and our y-axis is the vertical one. So to plot the point 1, 2, I'm just going over 1 on my x and up 2 on my y and plotting my point. My second ordered pair is 2, 4, which means I'm going over 2 on my x and up 4 on my right. My third point is 3, 6. So I'm going over 3 on my x and up 6 on my y. And my final point, 4, 8. Again, moving over 4 on my x and up 8 on my y. And then I'm simply starting at the origin and drawing my line through the points that I plotted. To identify whether a graph shows a proportional relationship is pretty easy. You just need two criteria. The first thing is the line straight? Second thing is, does the line go through the origin? And this is a must. It must go through the origin, or 0, 0. So let's look at the first graph. The first graph is a straight line, and it does go through the origin. So yes, this first graph is proportional. The second graph is a straight line, like we need it to be, but it does not go through 0, 0. Okay, so that automatically means that that second graph is not proportional. To write an equation from a graph, you need to find a couple points that you can use so that you have a x value and a y value. So when I'm talking about having a nice point, I'm talking about following your red line until you get to a point on the graph paper where that line intersects the graph paper right in a corner. So right here, I have a nice intersection with my graph paper. Let's find another one. Let's come up here. Okay, do you see how my red line right here intersects this blue graph paper exactly in a corner? Those are two nice points. So if you remember from our table, in order to find whether a table was proportional, we divided our y, or our bottom row, by the x, which was in the top row. And we did that for each ordered pair and made sure that we got the same answer every time. So if I look, well, first let me write this down. We divided our y by our x's. Okay, so if I look at this first point right here, the y value is 1 and my x value is 4. I'm still going to divide my y by my x. This time it's just on a graph rather than in a table. So my y value for this point is 1. And my x value for this point is 4. So if I divide 1 by 4, I simply get this fraction 1/4. Okay, I don't need to simplify it to a decimal. I can just leave it 1 divided by 4, or 1/4, because remember, this is a fraction and a division problem. We learned that back when we did a bell ringer a few weeks ago. Okay, so just to double check ourselves like we did in our table, let's pick another point. Okay, and do the same thing and make sure that we still get 1/4. All right, so I'm taking the y value, which is 2, and dividing it by our x value, which is 8. All right, and 2/8 does simplify to 1/4. Okay, so just like in our table, when we divided our y by our x, we called that our constant of proportionality. Okay, this is the constant of proportionality of a graph. That's how you find it. Same thing, y divided by x. And now to write the equation, we do the same thing. Okay, so our equation was y equals kx, where k is our constant of proportionality. We just found out that our constant of proportionality was 1/4. Okay, so there is my equation. And last but not least, we want to be able to identify what points on the graph mean. Okay, so we have, what do the points 0, 0 and 8, 2 represent? Well, let's think about talking about snail travels. Okay, everybody knows that snails travel very slowly. So my y-axis is the distance the snail travels in inches. So if we look up here, we have 1 inch, 2 inch, 3 inch. And on my x-axis, it's time in minutes. Okay, so this point, again, I'm my line color. So point 0, 0 is right here. What do you think that means? Okay, well, let's look. 0 inches, 0 minutes. So this just means the snail travels 0 inches in 0 minutes. Right? That makes sense, right? Why would your snail travel anywhere if no time passed? Okay, so now let's think about 8, 2. The 8 represents the inches traveled. The 2 represents, the 8 represents the minutes traveled, and the 2 represents the inches traveled. So 8, 2 means the snail traveled 2 inches in 8 minutes. Okay, so you're basically reading your labels for your x-axis and your y-axis, and you're just plugging the numbers in. Okay, so 8, 2, means 8 minutes to travel 2 inches, or he traveled 2 inches in 8 minutes. Simple as that. Good job, guys.